Alright guys, so this is the last part of section 8.2. So if you haven't watched the first video, make sure to do that before you watch this video because this video won't make sense without that one. Okay, so we're still going on with the arithmetic series, and now we're going to talk about the sum of them. Okay, so the sum of an arithmetic series, and remember, we can usually write this as, n equals 1 to whatever, 10 if you will, and then this is the summation. Okay, so we would use this when we see something like this. We're just going to add all the terms from 1 to whatever. In this case, it's 10. So here we're going to add up all the terms from 1 to n. Okay, and whenever we have this, we can use this formula. Now, if we're just talking about the first 2 or 3 terms, it's easy to work them out, find the first term, second term, third term, and then add them all up. But what if our n is like 186? We don't want to find 186 terms and then add them all together. That would be daunting. Okay, so we're going to use this formula. Now, when you use this formula here will be given to you. However, you will need to know what this formula stands for. Okay, so we'll give you this formula. You just need to know that this is the formula you use to find the sum of a finite arithmetic sequence. Okay, arithmetic sequence we've been doing. Finite, all that means is that this number here is not infinity. Okay, so any number here will work. Now, if this goes to infinity, we can't use this. Okay, but if it doesn't go to infinity, we can always use this term. But this is only for arithmetic series. All right, so let's look at example 5. Now, we could tell this is an arithmetic series because it's, I hate saying this, but it's kind of in the form of like a linear equation. That's a good indication that it's an arithmetic sequence, okay? Now, this is written a little differently. I just want you guys to realize that sometimes it could be written as this. This is the same thing as I is 1 to 20, okay? So 20 above here and 20 over here, these are the same thing, and you'll see these written in both ways. Okay, so the same thing as 3i plus 7. Okay, now we're finding the sum again. So if we go back to here, we know we can find the sum by using the formula. The sum of n is going to equal n times, parentheses, a1 plus a to the n over 2. Okay, and remember this here is our n. So really what I need to find is our a1 and our a sub 20. Okay, so a1 can be found by plugging in 1 in for I, so 3 times 1 plus 7, which is just 10. Okay, and then a sub n or a sub 20 can be found by 3 times 20 plus 7, which is just 67. Okay, so my a1 and my a sub n are here. So I'm going to plug that into a1 and a sub n. Okay, so the sum of all n integers, and n here is 20, is, 20 times a sub 1 is 10 plus a sub n is 67 over 2. Okay, so this is just 20 times 77 over 2. And if you wanted to do this without a calculator, think of this as 20 over 1. That is just 10 over 1. So this is 10 times 77, which is just 770. Okay, so that's a whole lot easier than finding the first 20 terms and then adding them all up. All right, so I want you to use the example on A. Okay, now pause this video and I want you to try to do example B on your own using A to kind of follow. All right, so here's B all worked out. Once again, you want to find your a sub 1, so when you plug 1 in for n, you get 4. Then you want to find a sub n, and your n here is 18. So when you plug 18 in, you get 106. And then when you put it in the formula, you get 18 times, parentheses, a sub 1 plus a sub n, so 4 plus 106 over 2. And then if you reduce that and do some math, your final answer should be 990. All right, let's look at our last example here. Let's look at example 6, okay? So we're building this tower with cards, okay? It says you're making a house of cards similar to the one shown, okay? So write a rule for the number of additional cards in the nth row when the top row is row 1. Okay, so this would be row 1, this would be row 2, and this would be row 3. And of course we could go on and on and on. Okay, so if I look here, notice my row 1 has 3 cards. Okay, now if I count these 3 cards in row 1, how many additional cards would I need for row 2? Well, here's 1, 2, 3, 4, 5, 6. I need 6 more cards. Okay, for row 3, I would need 1, 2, 3. I've already counted the top. 4, 5, 6. Already counted the top. 7, 8, 9. I need 5 additional cards to complete row 3. Now notice here, I have an arithmetic sequence where I'm just adding 3 every time. Okay, so I want to write a rule. So to write a rule for an arithmetic sequence, remember we have to show it's arithmetic first. I know all arithmetic sequences. I can write a sub n equals a sub 1 plus n minus 1 times d. Okay, well my d is 3, and my row 1 or a sub 1 is 3. So I can rewrite this as a sub n equals 3 plus 3 minus 1 times d. Sorry, I screwed this up. Times n minus 1 times 3. That looks a little better. Okay. Now if I clean this up, I'd have 3 plus, I distribute this 3 through, 3n minus 3. So a sub n would just equal 3n. Okay, so here's my rule. All right, so now that I have my rule, I can go down to part B, and it says, how many cards do you need to make a house with 12 rows? Okay, so I want to keep going to row 12, and how many total cards I would need would be the sum of all the rows. Okay, so I could say I need the sum from row 1 to row 12 of my equation is 3n. Okay, now remember to find the summation for an arithmetic sequence, guys, that would just be S sub n equals n times a1 plus a sub n over 2. Okay, now I need to find my a1, which is 3 times 1, which is just 3, and my a sub n, my n is 12, is 3 times 12. I'd have to add additional 36. Okay, so to put it in this formula, I'd have n times, my n's 12, times a1 is 3 plus a sub n is 36 over 2. Okay, once again, if I wanted to do 12 over 1, 12 over 2 is 6, so this is just 6 times 3 plus 36 is 39. And when I put that into my calculator, I get 234 cards. All right, if you feel like you need some more practice with the summation and using the summation formula, go ahead and work through these 2 monitoring progresses. Go ahead and pause it, work through them, and then I will pop up the correct answer with all the added work with it.